Hey Matt, what's up?
Not much. Happy Monday.
Yay, Mondays. TGIM.
We're back
Always
at it.
excited about Mondays. Yeah, back at it. Did you have a good weekend?
I did. I did. It was pretty low key. Did some like kind of street hiking stuff this time to avoid the storms you mentioned last night. And
What's street hiking?
just like, did like a 45-minute basically walk around my neighborhood. So
Okay,
yeah, given the storms, I didn't want to, it was getting late at that point after the storms had cleared. So just,
right on.
yeah.
That's kind of what my friends do. They go rucking. So they wear heavy backpacks and walk around the city. They look
Okay, that's
like a
funny.
gang of weird people, I'm sure.
It seems
So
like a bad idea right now. Like you would probably you'd attract some kind of scrutiny that you wouldn't want. People would think that you were up to no good if you were carrying a big heavy
yeah,
backpack.
yeah, definitely. Exactly. Yeah, it's funny. So well, that's cool. Yeah, so I think one thing we definitely want to talk about, I think, is something that we always kind of quip, which is that most companies can barely do BI, let alone AI. This is, I think, a theme that keeps popping up over and over, and I think it was actually one of the reasons we started Ternary back
I
in the
mean, I would say it's
day.
the main reason, right? Like we kept seeing problems just with core structured data, inability to process core structured data, inability for analysts and data scientists to kind of improvise and do this dynamic querying that they need to do to explore data, and then data
Yeah,
quality
definitely.
again and again and again. Yeah.
hmm Yeah, for sure. Like, I can't. I think I lost track of the number of companies I've seen where they've hired data scientists and then realized that not only did they not really have anything for the data scientists to do, but uh, they didn't have the infrastructure in place to I would say do proper analysis of their existing data, and so and more highlighted that BI was lacking in these companies.
Yeah. And BI is a
So
really tough problem, right? Like you can have a very organized ETL development team, and yet it can still take like 6 months to deliver a data change to fix data quality issues. And that's a big problem for data scientists because frequently by the time the data gets into a data warehouse, all the metadata is gone. And so they can't do their own low level cleaning at that point. Like they're just stuck with it. And you have all this noise in there that is going to obscure any signal that will bring out interesting insights.
what do you think? What do you think we can trace that back to?
Ooh, that is a good question. Um, there's this tension between having organized processes and having creative processes. I think that's part of the issue here, right? And so I think traditional ETL development is focused on maintaining the integrity of the data. And so as a consequence, they often cut off a lot of access to teams that want low-level access, and they move very slowly. But then what happens is the data integrity kind of degrades on its own over time. In other words, things change in applications, things change in third-party sources, and they just can't keep up with those changes. And by the time they catch up, there's another data problem. And then when data scientists, again, try to run that through models, they get junk. It's the old garbage in, garbage out. If your core data is not high quality, then you're going to have problems.
Yeah, I tend to agree. I think that, like, especially more kind of legacy ETL approaches and um, even old BI approaches. I mean, it was definitely like the opposite of agile in a lot of
Mhm,
sense, right? Like,
mhm.
you want to talk about the epitome of waterfall techniques. Look no further than sort of incumbent ETL and BI workflows in most companies. I mean, so it's. I mean, the fact, as you mentioned, that it takes like 6 months to make a change, which is not uncommon. A lot of
Right.
companies make a change to a field. That's ridiculous in this day and age where data ops and agile and quick iteration is more of the name of the game. Especially, there's a dichotomy too I see between like data scientists who tend to operate more in a code environment, and then your traditional ETL teams that tend to sort of use like legacy workflow tools like the Informaticas or the Talons out there that are I think very rigid in how data is pipelined through them. And that's not to say that these tools aren't useful and BI, legacy BI isn't useful. I mean, it's tremendously useful, but um, and what we see over and over again is even companies that would be doing, that even have BI in place, I can't say that they're living to their fullest potential with BI, right?
Yeah, and I
So
think we're, interestingly, we try to avoid talking about technology as a solution to organizational problems, but I would say that we're both also really big advocates for SQL. That SQL is like this amazing tool if you use it appropriately, if you have the right system. So if you're using SQL in a very constrained database system where you can't really create new tables and you can't run large queries, that's not going to work for data science. But if you have like a really flexible environment where ETL developers, data engineers, data scientists, ML engineers can work together and develop these very powerful pipelines, then potentially you can serve data quality and integrity and also serve the creative side of delivering value quickly from data science.
yeah, and there's some good players in the field. I mean, our friends over at Great Expectations, I think, are working on the data quality issue.
Yeah.
Data quality as code. Then DBT is capturing a lot of mind share right now with their approach to sort of a code first data transformation using DBT. And I think it's going to go a long way towards sort of changing the paradigm and hopefully making that bridge of I would say modern BI approaches where you're able to well, let's step back and maybe
Yeah.
talk about like legacy BI. I tend to couple that into, or I tend to group that into, you have your reporting department, right? And it's just a very hierarchical system, right? Like you have your ETL team over here and your reporting department over here, and execs get the reports, or you say the business gets the reports that they're handed, and that's just kind of how it is. There's not really a notion of like self-serve analytics, which I know is sort of a cliche at this point, but the data isn't what you see is what you get, and it's kind of all you get unless you want to go through a 6-month change process for your report. And so what that means though is the business really can only take the actions given the data that it has, which means that the business isn't able to respond as quickly as it should, especially in these days when rapid response and agility is I would say it's not even a luxury, it's a necessity. And so by definition the information you get is sort of influences the actions you're going to take. Sometimes you don't get information, and sometimes you just do gut driven responses or something similar, and that tends to be I would say common. But what it means too is like when you try and get data scientists into this mix, it's usually a hopeless endeavor, because if you can't even make good decisions on the based upon a set of reports, and by good decisions I mean decisions that are actionable and timely, right? So if I get a report, I can go take action on that today, like right now, and influence a better outcome for the business. So
Yeah, and I mean, the problem is that if you have bad signal in your data, it's worse than flying blind, because instead of saying, okay, I don't know what's going on, it's dark in here, let's be very careful, businesses respond to the bad signal and often do really terrible things as a consequence, right? Like they have this noise in there and that's what they're reacting to. It could potentially cost you a lot of money and cost you a lot of sales.
mm-hmm. Yeah, definitely. And and if you try and do machine learning, for example, on top of bad BI data, I mean that's a nightmare. I mean, in general, I've worked on this problem for a while, which is machine learning on structured data, and I guess more specifically machine learning on unstructured BI data. And it's an interesting conundrum you find yourself in with BI data, because in a lot of cases, I mean, you kind of already answered the question that you're asking, right? So because in BI you've inherently structured your data in such a way that it makes sense about your business, and you've modeled your business in such a way that hopefully you're able to derive insights out of that. So machine learning is an interesting one where because the data is already formatted in a way to answer questions, most questions are answered, and you don't need machine learning.
Yeah,
some people argue with me about this, but I mean, I've seen enough examples where I would need to be I'm pretty stubborn. I need to be shown a pretty good example of where that defies what I just said. So,
well, and I would argue too that there are problems in data science that can run on top of business data and extract an interesting signal. But if you can't get the data in good enough shape for humans, then what makes you think that machines are going to be able to get some insights out of it? Like the same bad signals are going to be there if it's structured improperly to answer business questions, the machines may not do a lot better than humans. And they may even do worse
Right.
because they have the instinct to understand this is not how this business actually works. I think sometimes humans can look at the data and understand the problems inherently and kind of work around them. The machines just take what they're given and then return a model back.
And that's and getting the data set for machines has always been the hardest part of machine learning and structured data. It's like, I think doing machine learning on video or images or unstructured data is actually easier than doing machine learning on structured data, because structured data is human generated most of the time. Structured data can be messy, and there's just all kinds of there's a ton of things that can go wrong with that data set. And if it's in rows and columns and it comes from a database, there's always there's always feature engineering that needs to be done, and it requires domain expertise usually. Like I've worked in AutoML for structured data, and I think the biggest issue I always saw was when you would take a structured data set and just try and blindly apply algorithms to it. 9 times out of 10, if you don't have domain expertise, you'll get an answer. I can't say it's going to be the right answer, but you'll get something, and that's actually really dangerous because now you're blindly assuming that you have some sort of predictive capability on this data set, which may or may not be there. It could be a mirage. Don't know.
Like there's a whole semantic process that has to happen with structured data. So if I'm a human, hopefully I understand how my business makes money. And if I'm doing business analytics, business intelligence, I'm focusing on those things, and I understand what different fields mean as far as the company making money. But you have to teach a machine to understand that. The machines don't come into this with an understanding of how business works. And so part of teaching the machines is to restructure the data appropriately. In other words, do feature engineering, which in the modern world often comes down to SQL before you feed it into this model generator.
Yeah, and it comes back to most companies can barely do BI, let alone AI. And I would say, like, do BI well, and I would and understand your data, do great analysis. There's analytics is sort of a 4-letter word with data scientists these days, but because I don't know, I sense there's some sort of superiority complex with data scientists versus analysts. But your business can get a lot of value from just doing great BI and getting actionable, timely reports. Nothing wrong with that. In fact, if you aren't doing that, you're jumping straight into doing AI. I would say you're probably gonna have some pretty expensive mistakes occurring. You're going to regret the decision. I mean, again, there's so much value in just doing really good analysis in the data that you have, and shoring that up before you try and apply machine learning to it. I mean, machine learning works best when you have processes that are unscalable for a human being to do, right? Like pattern recognition on tons of data. That tends, so if you were to analyze a lot of images, for example, right? Like a human being could do that, or you could just have a computer do that. Same with text and everything else. So, yeah.
And again, the BI processes are a prerequisite when it comes to business data. Those BI processes are a prerequisite to machines understanding that data. Like you still have to get it into shape. And it turns out to be a very similar problem for preparing it for humans and preparing it for machines. So like data quality, you need data quality in both cases. And so just develop that core process that will feed into both of the use cases. And going back to what you were saying about like trying to skip over BI and jump straight to data science, in some cases, this ends up being like stepping over the $100 bill on the sidewalk to pick up a penny. Like, yeah, there could eventually be a $100 bill in that data science, but your immediate value, the low-hanging fruit is your BI first. And then that will build the foundation for your data science later on.
Yeah, definitely. It reminds me of like some conversations I used to read on social media back, I think it was maybe the middle of this decade, where machine learning was popping up and everyone was really excited about it. And they're like, oh my God, like we don't need to do reports anymore. Like data science and AI is going to completely remove the need for analysts and SQL and all this other stuff. It's just garbage. And, maybe someday it'll happen. I don't know. It's hard to predict the future. But here's the deal. You need data to make that happen. Right? That's the insight that we had a long time ago, I would say before it was cool. Where it was just, I think, a really early recognition that, yeah, in theory, sure, like AI could take over all these jobs, but uh, that assumes you have great data to work with. And guess where that data is generated? Well, it's usually people punching in data. And guess what happens with that process? Like there's errors and all kinds of stuff. So you need data quality, you need to understand the data, you know, you need to apply domain expertise and so forth to it. Like, and again, having worked in AutoML, you know, enough of it, it's just, I walked away convinced that this is, um, the hardest part isn't the algorithms for AI. The math is the easy part. Getting the data set's the hardest part. It always has been, and as long as structured data is around, it always will be.
Well, what we're frequently finding is that like a multivariate logistic regression is all you need to get a lot of value out of your data if your data is already in really good shape. But it has to be in good shape first. Like you have to be pulling out the business insights that you want that logistic regression to work on. And I think Amazon found that fairly early on as well. Like just focus on these simple algorithms, but really make sure that the data is in good shape and that you have enough of it to get what you want. And going back to your comment about SQL, I think people have been dismissive of SQL, especially like 10 years ago, but we found that over time, SQL has become much more powerful because the engines running it have become more powerful in the process.
Absolutely. Yeah, and it's interesting seeing SQL become more of a like a data science language now, because again, for the longest time, data scientists were either in the R or the Python camp, and
Right.
what's funny is seeing data scientists now recognizing that, oh, if we want to be more effective, we should probably do SQL as well. I mean, that's it's cool to see that for sure. It just you know, I think there's a lot of cargo culting in data science.
Yeah. Fancy tools, right? Like Spark is the latest thing. And I'm not like denigrating Spark. I think Spark is a great framework, but the thing is, Spark is not magically going to make your data better or allow you to apply new logic to it. Like there are a lot of tools that can do the things that Spark can do. So you really want to focus on what you're trying to get out of the data, not the particular tool that's doing it.
Well, yeah, I mean, look what's happening too. The uh, you know, with Spark, you know, it's mostly SQL now,
So
actually.
a lot of
And
Spark.
so,
It's
I
true.
mean, so at which case, yeah, at which point you're kind of wondering, well, what could I do in a data warehouse using SQL that I couldn't do in Spark? I mean, there's quite a few things, you know, if you want to take a more of a programmatic approach, but if you're just querying a data frame, like that's literally no different than querying a table, right?
Exactly.
So
Yeah.
I'm like, but
Yeah.
it's you know it's just the cycle everything goes through. I think it's you know, it won't be the last. Or it's, you know, it's still early days in data as well. I mean, you know, in data science, and but what's old is new again. And it's interesting seeing, you know, in our path as well, just how, you know, I think when we started, we wanted to help companies succeed with data science, and I think now we're more realizing, well, I think we need to help companies succeed with BI, because
Mhm.
it's sort of a precursor to doing anything else. So
Yeah. Yeah, absolutely. And actually, that I think we'll talk about this another week because the resurgence of SQL is a whole theme unto itself. But we frequently find that there are opportunities for teams to really level up on their use of SQL. And part of that is just bringing programming practices from data frame languages into SQL, which is very doable. What we tend to see is that like people tend to try to collapse all tons and tons of logic into one query. And then it gets to the point where you just can't understand it anymore. And you need to take at some point more of a procedural paradigm with SQL maybe, and think about going through a bunch of different steps and then understanding the logic in each one and understanding where you want to get to as your endpoint.
yeah, totally. And and as you go through those steps, the cool thing is you start understanding your data and how it
Exactly.
applies to a domain, right? And that's that that tends to be, I think, one of the more overlooked skills as well, is established, you know, with data scientists, especially when they start out, like
Yeah.
they want to come into a company and apply all the latest, greatest, uh, you know, machine learning techniques, sometimes without even understanding what the data are, which
Yeah.
is kind of shocking. But maybe I should, you know, maybe it's not too shocking because, um, you know, you have the machine learning hammer, and you know, you have a whole bunch of nails and you want to start hammering away. That's a temptation. So.
Right. Yeah, we've kind of developed this outlook where algorithms are magical and you just apply them to data and something amazing pops out. And the reality is the algorithms at this point are pretty banal. They're just kind of standardized tools. And it's all about, well, it's three things really. It's preparing the data, it's choosing the right algorithm, and it's tuning that algorithm. And if you can do those three things, then you can get a lot of good results, but you have to be able to do the first step of getting, cleaning, preparing the data. What's the cliche? It's like you hear something between 75% and 85% of a data scientist's time is just spent preparing data. And I think part of our outlook is we want to automate that more. Like we feel like if the business intelligence processes get better and they're more collaborative with the data scientists, then data scientists can spend more of their time focusing on the high value portions of their job.
Right. Yeah, like actually doing the science part of data science versus doing the data part of data science, right?
Right.
So,
I mean, think about, the whole big data craze a few years ago. And by the way, big data is even more important now than it was a few years ago. It's just that it's not a craze anymore. It's an off-the-shelf tool. But back then in the early days, you had developers spending a ton of time writing these complex MapReduce jobs to do something that was actually fairly simple. And so I think if developers and data scientists spend their time on the more modern tools that can get through those preparation stages quickly and deliver high quality data, then they can get a lot more value in the remaining part of their job.
Yeah, definitely. Well, cool. Well, I think it's maybe a good place to end for Monday morning data chat. But yeah, as always, good chatting about this. I think it won't be the last time we talk about this topic either. It seems like most of our conversations are like some derivative of this.
Yeah.
Most companies can barely do BI, let alone AI. And so, but yeah, I think, looking forward to next week. I think talking about maybe the resurgence of SQL, maybe a good topic to go on, something we see often. So
yeah, we'll talk about resurgence of SQL, more modern tools that still run on SQL, and why SQL has kind of obtained this, it's developed this bad reputation, going back to the 70s. Over time, its reputation has declined, and we'll talk about why that is.
Yeah, awesome. Well, enjoy your Monday, Matt. We'll talk to you later.
Take care.
All right.